Okay, so today we'll be going over a more abstract paper. This one is actually by Lex Fridman. Um, you might have seen him if you are part of the MIT autonomous vehicle group. Then uh, you probably have seen his videos and and all that. Actually, I believe this study was mentioned in one of his talks with Elon Musk. Um, and I found it somewhat interesting. Um, but anyways, let's get into the gist of the paper. So this paper is actually quite long. So the first part it mentions about the study about how about the I guess study of human behavior along with use of autonomy and um, and how the study was conducted and all that. The second part it goes into hardware and uh, and then also going into software, how the system is set up. Um, I wouldn't say I fully understand all this down here, especially once it gets into hardware, because it's like I haven't been working, never worked as hardware mechanic or etc. But I'll do my best here. So yeah. So up here, let's see. Essentially, mental model. Mm. So yeah, just it's it mentions here that full autonomy is still a great ways away. Still very big challenge. Let's see, mental model information change rover. So this study was conducted on with 122 participants over let's see, 1,000 days, 15,610 days of participation. I believe that is average over all these people. Uh, 51,000 miles of data and so many billion video frames. Right. Present design of study, data collection hardware. One thing I'm curious is that here. Let's go to the last what we call one thing we mentioned here. This was the Fast and Furious paper. Upload. And I believe I could be wrong though. No, I saw that it was about the same amount of data, but it was not. So I was wondering if this data was shared and reused. I don't believe so. Let's see. I thought I remember that. No, it was not. All right. So as opposed to well, this study, as opposed to studying how you can as opposed to studying how you can add autonomy to the vehicle, it really is a study of um, regarding it's a study of the driver and how they interact with the vehicle. Lex Fridman, he believes that um, over here in this paragraph or this section here, he believes that the human driver is still required for for at least in the near term for autonomous vehicles because he believes that fully autonomy it's a great challenge. Despite that, the characterization that humans are bad drivers, or at least he put it. And to be fair, humans are bad drivers. Reason being is that humans are not really meant to go like 80 miles an hour or stuff like that. Cheetahs are better equipped at doing things like that. You know, but anyways, let's see. It's essentially, so yeah, they mentioned that during DARPA was believed that fully autonomy was quite underway, but that is not quite the case. So see, there is a lot more edge cases that weren't really explored in DARPA Grand Challenge, or this wasn't Grand Challenge, the Urban Challenge. Grand Challenge was the one where it was driven on the freeway, I believe. It's not really freeway, but it's more like in a desert area. I believe it's one of the first videos that you have seen taking self-driving car now degree. Visualization GPS. So this is just a map of where the study vehicles have been driven. This is the New England area, and some of the other states this expands into. Right, acknowledgement. So personally, I don't, I don't really buy into that. I mean, full autonomy is going to take a while, but I don't buy into that human drivers will be needed for like 30 years or something like that. But I do believe that this study could give some insight as to some of the information that is needed for obtaining full autonomy. It's always good to study like the driver behaviors, all that. Uh, you don't take this. Okay, so they're mentioned here. They're the naturalistic driving. So they are the experiment they done is using the naturalistic studying model. Um, Essentially, what this means is that it lets the it lets the people drive however they want, or naturally. I'm guessing since the screening, you can see there was screenings done. They're not going to take some maniac driver whose driver's license has been suspended 3 times or something like that. But yeah, essentially it's not really saying constraining the drivers to make turns or things like that. Trying to have more natural behavior of the participants. Constraints. Yep. Essentially, that's what's mentioned here. This is it's mentioned that this is a new generation of NDS because they're trying to get a lot more insight. Previously, there were studies that are, you know, the previous studies they just don't give a lot of information. It's like essentially they collect information on what happens to like what the driver do during a accident and all stuff like that. But this study takes a lot more information, gets a lot more information. So what's being studied, right? Autonomy at all levels. So anything from the Tesla what you call auto cruise to autopilot, yeah, autopilot to things like just lane keeping and automated braking, for crash safety and stuff like that. So this also goes beyond just menu, epochs and menu. annotations. Right. So yeah. Let's see, parent process or high definition video. Yeah, because manual annotations won't be able to handle all this information, so they do have to do some kind of processing. Tail computer. Yeah, so this is the long tail means outside of short easy to epoch. Moment to moment glance. Yeah, so it's just I would say it's a lot of information that's not easy to decipher. Multiple study duration, post long term. So they took different durations. So some participants have like took 1 year for the own vehicles, and the other one took medium term 1 month. Multiple analysis modules. And so use a lot of stuff, computer vision, expressive knowledge. Okay. Also use GPS, MU, CAN bus. So there's 3D information as well. GPS is a location information and all that. So the good information for GPS is it can tell you where the drivers are. So if they have they disengage autopilot, for example, you can see how and why they disengaged. Maybe it is at a busy intersection, or it really is. It's not. It's just parts that are not easy to drive, and stuff like that. Right. Okay. Drivers. Okay, so this just sums up the study. Uh, measure here 37 months participant days. So this study was conducted over this many months. Of course, not everybody participate for the full 37 months. A lot of people, like as I mentioned, a lot of people participate for 1 year. Some participated for like 1 month as well. Holistic model. Okay, contrast. Okay, so I just mentioned about the different studies. How perception, their experience. Okay. So yeah, you mentioned about deep learning can be defined in two branches. One is the machine learning that you know use neural network with many layers. The other one is that form hierarchies with minimal input from human hierarchy. So they are leveraging. So this is the advantage of leveraging here for key characteristics important to work. Uh, okay, image driver power deep learning. WordNet. Okay. And total just common work. Light. Okay, so they have reused ImageNet for their deep learning, and these are some of the different data sets that were available. You see, there are Coco is one of them. Kitty is vision optical. Um, okay, Dometry, Cityscape, Camvid. Okay, perception, control system. research, facial recognition. So yeah, they just mentioned these are things that are used in deep learning. It, these are more specific to autonomous driving state prediction. Essentially, so this is things like a person falling asleep, or yeah, they're about to make a turn, etc. Semantics, scenes, perception. So, I think perception to detail. Oh yeah, so this is the semantic segmentation. You touch stuff like this in like the second term, or I mean it's an option. You can choose segmentation for your elective. Let's see, body pose estimation. It's estimating a body pose, and facial recognition. You can see an example of this up here. There, recognizes driver and their face, where it's located, etc. Principal underlying design on hardware level. Edge processing, Jesus. Okay. Yes. Okay, so this is just mentioning about the participants. Um, for the participants, they do conduct or take inquiry. So yeah, the participant has agreed to install the IRB board. This is essentially start to collect the data. Primary driver and yeah, so potential subject they commute. Okay. Of course, there are secondary drivers as well. Confirm consent. Uh, so essentially, yeah. So there's a questionnaire that is given to the general drivers. So before questionnaire prior after natural. So these vehicles. See, MIT owned vehicle router. Issue into primary secondary driver. So these are 1 year study, and I believe these are the MIT vehicles. Okay, no. Okay, so the MIT ones are 1 month, and the 1 year is subject owned. On subject owned vehicles, participant 1 month. Yes, training session. So for the 1 month participants, because these people are okay. So these people are the 1 year participants. They already know how to drive their car, so they don't need the of course, they don't really need training because they already been driving. Of course, they screen them for criminal records, etc., and all that stuff. Make sure there's no crazy drivers and all that, and they're not going to misuse the device they have, stuff like that. Or I mean, of course, like you don't want to just somebody install their device and just sold it the next day. Okay, how to adjust their mirror. To be fair, I think this is a little too much hand holding here. How to adjust their mirror, touch screen, etc. Because I don't think I get this much introduction at a lot of the dealerships, and you buy the vehicle still. So, um, but I mean, it kind of makes sense because you want people to use the autonomy. You don't want them to just never touch it, so it kind of makes sense. Qualitative approach for 1 month and the support. Mm-hmm. Okay, so essentially these people, they take a questionnaire before, and they take questionnaire afterwards. Okay. Mm. And so um, these questions are things like how confident they are in the let's see, how confident they were with the autonomous, like the technology, and how comfortable they were afterwards, and things like that. Um, okay. Okay, conversion consortium model. Yeah, there was a lot to cover, um, and I don't think I got a lot of time on this. Passing uncertainty risk potential costing me as much. Okay, so all this information. So this information is could be potentially valuable to certain parties. Here's our car companies, automotive parts supplier, insurance company, technology company, government agency, academic research organization. It helps people know, understand, um, essentially educate them on um, the autonomous driving technology, and as well as human behavior subjected with autonomous vehicle technology. So essentially, like for car companies, they can, they can see how what people are really comfortable with and stuff like that, right? What doesn't work, you know? Okay, backbone success measures study. Because you always do need an audience when you conduct study. It makes sense to have audiences. If it doesn't, you don't have an audience, then it's like it doesn't really make sense for you to conduct a study. Um, okay, so here it's introduce the components of the pipeline. Um, so what they do. So the backbone of the naturalist study is the rider system, real-time intelligent driving environment recording. So this is recording all the information. Um, so I'm not sure if you guys have worked with insurance company that gave you a little plug. It's like a little it's like a USB, but it's a lot larger. You, what happens is that your insurance company with you plugging the I guess this recorder will reduce your insurance by a certain percentage of your premium. So this is similar to said device, but there's more to this because with this uh, there's also a camera mount um, and high definition video. So they have three cameras on this. So this is a little bit slightly more complicated than what your insurance company would have been giving you, but you can think of a similar in similar fashion that it can be easily installed in a lot of new vehicle programmable new vehicles, right? So there's a Knights of Camelot controller power board. So this is the Knights of Camelot controller power board. This is the microcontroller board they use. Uh, Essentially, this it controls the power for the rider system, right? Um, okay, expandable. So, as it goes into the hardware, I start to not really have full grasp of what is going on. There's an ARM processor feature on board vehicle for telemetry. This ARM processor, I believe it's yeah, it shows up on Banana Pi Pro. Uh, um, okay. Yeah, so Banana Pi similar to Raspberry Pi, but um, this is optimized for robotics rather than as you know, Raspberry Pi is already optimized for robotics. You can have like pet projects on it, but it's not going to run it's not going to run smooth. It's rather slow. You need a better board. This is one example of that. There's a Huawei LTE USB module. Trump's not gonna like that. Let's see. Actually, no, it's not. I'm not even sure if not even sure if Trump is the one that. But anyways, what you call the Trump? Uh, blah, 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 blah. Anyways, onwards. Camera 3R4 Logitech C92 camera. Okay, 30 frames. So this is a pretty fast camera. Or second. This is I don't know. I say it's average actually. Two. Actually, I think this is pretty good. But actually, if you think about this, if this camera is 30 frames per second and Fast and Furious was, uh, I'm curious. So I'm jumping around the papers, but yes, yeah. So the work was 33 frames per second, which actually already exceeds this camera. So you can see that how good the performance was from the last paper. Okay. Final prototype version, writer enclosed by 3D printing case. Right. So this is what it looks like when it's assembled together. Webcam mounted windshield. Right. Startup script. Single board. Okay. Single board computer. Startup script. Microcontroller stuff. There's data recording, initializing. Okay, Doki. Yeah. Anyways, let's take a quick look at architecture and our pipeline more or less. So writer logger, hardware, heartbeat, light processing, offboard. There's okay, so this is not a lot though. This is light processing. Essentially, there's not a lot of processing going on here. Offloading processing queue. So there's an processing queue. Okay, synchronization. So this is you can see this is 100. Above this is in the medium data, but of course they get synchronized, and um, when it's in process getting synchronized and put together, um, this put together is a huge data. So this is a private trip data. So it's from like you driving from, let's say Toronto to Bern or something like that, right? And that's a lot of information there. 100,000 gigabytes here. So removal requested, perform requested removal, non-consent subject. So essentially any driver that's not supposed to be captured, they're gonna get removed. Requested removal. So sometimes you say I don't want this script to be recorded. For whatever reason, it gets removed. Maybe you were having you were doing something a little bit. Well, let's not go there. um, but yeah, so after that, it gets knowledge extraction, semi-autonomous annotation menu, and then epoch extraction, visualization. So after all this, the process epoch data and visualization, they are They're still large, but they are manageable. It's big data, uh, and it's around 5 terabytes. That's it will still be within manageable range. Of course, you do need a lot of processing power and architecture, like parallelization. Um, you can use Hadoop or PySpark, etc., to handle this data, analyze it, etc. Um, so okay, so down here it starts going to the hardware. Okay, so mentioning how about software, some of the software here. Okay, but yeah, let's just go to the conclusion. I don't think we'll just jump directly to the conclusion, but think it's a fine time. First, the art had some programming, breaking grounds, changing transportation, basic study behind them to study, some approach, collaboration, track panel, human interaction, bears level of technology, higher drawing experience and large scale human expertise. Okay, so yeah, essentially they this is a it's conducted experiment human expertise. Okay, right. So this is more of a hybrid study with both of technology and human expertise. Of course, statistical size and scope of MNT. Data set updated regularly on this here. Let's take a look. Okay. Okay, this is summary and okay, so there are more days of participants. You can see this is it has been updated, right? Let's see. Let's take a look here. Been updated. 18,610, and this here is yeah, no, this was not updated. Damn man. Lex, why you be lying? Alright, anyways, I think that will do it for today. Thanks for coming.